Hello and welcome to this quick look at a combined spectroscopy leveled response 6 marker. It's from the June 2019 OCR Chemistry A Synthesis and Analytical Techniques question 21. So looking at the question, you've got 4 pieces of information. The best way to do this is to lay out something like a sort of section for each one, and under each section you can focus on that part of the question alone. So that means the processing is a bit easier. So starting at the top where we've got the elemental analysis by mass. First thing to do is to take each element and divide the percentage by the relative atomic mass. That gives you a ratio, and to clean the ratio up so that it's whole numbers, you can divide everything through by the smallest, which happens to be 1.219375. So that gives us C5H6O as our empirical formula. Now the mass spectrum tells us that the molecular ion peak, or the largest fragment in other words, has an MZ value of 164.0. Now 82, which is the equivalent mass of the empirical formula, goes into that twice. So that must mean the molecular formula is in fact C10H12O2. Now the fact there's 2 oxygens allows us to consider the possibility of a carboxylic acid, which is what the infrared spectrum is suggesting. You've got an OH carboxylic acid peak and a C double bond O peak. Now with your hydrogen NMR analysis, first thing to do is to label the peaks. And you can do this analysis using a table method. So next to each peak you put the chemical shift value, the chemical environment from the data sheet it represents, the splitting pattern you write in words, which gives you the adjacent hydrogens, and then the RPA, which is the number printed next to each peak, is the relative peak area, which tells you the number of protons in that environment. So working your way across with each row, that allows you to change each chemical environment into a conclusion. In other words, what actual environment does it mean? So taking these and piecing them together, that gives you 3 possible structures. So looking at the NMR table, you can see that all 3 are possible structures, but for peak C, the conclusion we came to is represented in each of those structures. So that's quite a key conclusion to identify the compound. Now you can obviously see there's a CH3 attached at various points. So peak D will allow us the relative positions of the substituents, so you can move the CH3 around a little bit each time. Okay, hopefully this has been a useful look at what's quite a challenging question actually. Until next time, thank you for listening and see you soon.